The average American home inspection finds 3 to 5 defects per visit. But what happens when those defects were baked into the house from day one, buried inside the walls, under the slab and above the ceiling before you ever signed the papers? A yard that looks perfectly level can hide a costly secret. Beneath the surface, the slope of the soil, barely noticeable to the eye, determines whether rainwater flows safely away or seeps under the foundation. California's Residential Code, Section R401.3 and Appendix J require a minimum 2% slope away from the house, yet this detail is often missed or ignored. A 2018 survey by C. Schultz Home Inspections found that 38% of homes showed grading or drainage problems linked to structural movement. FEMA's own data ties 23% of residential foundation failures to poor grading. On paper, municipal codes demand surface drainage to a storm sewer or approved outlet. In reality, the site superintendent may skip soil compaction or fudge the slope to save time and money, especially when the final grade will be covered by sod or mulch. The engineered grading plan meant to protect the foundation gets lost between the architect's desk and the field crew's shovel. Once the landscaping is in place, the illusion of a finished yard conceals any reversed or flat slope, while subsurface drainage pipes, if installed at all, disappear under concrete and dirt. Unless a laser level or grade survey is performed, these errors remain invisible, setting up moisture intrusion and foundation movement that can cost tens of thousands to repair. The code is clear, but enforcement is weak, and the first opportunity for concealment happens before the house is even framed. Inside the crawl space, a different kind of shortcut takes hold, one that's invisible to anyone standing above ground. The International Residential Code Section R408.2 requires a continuous Class 1 vapor retarder at least 6 mm thick to cover every inch of exposed earth. Yet in practice, builders often cut corners. Instead of overlapping seams by the recommended 6 inches and taping them tight, crews may leave gaps or skip taping altogether. Sometimes the barrier is missing entirely, especially if the builder believes natural ventilation will do the job. According to Americova's code review, this is one of the most common failures in new construction, and it's rarely caught during inspection. Municipal inspectors typically check only for the presence of a barrier, a quick glance, not a thorough check for breaches or missed overlaps. But even a small gap allows ground moisture to rise, feeding unseen humidity into floor joists and subflooring. A moisture control specialist explains, when the vapor barrier isn't continuous or the seams aren't sealed, humidity levels spike. Over time you get mold, wood rot, and even structural damage, issues that can cost tens of thousands to fix. StegoCrawl's best practice notes confirm that missed overlaps and untaped seams are the weak points. The 2015 IRCR 408.4 also requires a crawl space access door at least 18 by 24 inches, but undersized or patched over entries make future inspection nearly impossible. Once the floor is finished, any defect in the vapor barrier is locked away, setting up a slow, hidden pathway for moisture to invade the home's structure and air. A structural header sits above every window and door, carrying the weight of the roof and upper floors. The International Residential Code, Chapter 4, spells out exactly how big these headers must be based on span and load. Yet in production homes across the country, many framers default to a double 2x8 or 2x10, regardless of the opening's width. According to the National Association of Home Inspectors, 1 in 5 new homes has an undersized header, a hidden flaw that will not show up until the drywall cracks or a door will not close. A structural engineer explains the difference between a code-compliant LVL header and a double 2x8 is not just a number in a table. It is the difference between a wall that holds up under snow load and one that sags or even fails. The 2021 IRC span table, for example, requires a double 2x12 or a single 1 and 3/8 inch LVL for a 6-foot opening, but many homes get only a double 2x8. The cost difference? $30 to $40 per header or $600 to $800 for an average house, pocket change in a six-figure build. But once the framing is covered and the house is sold, this shortcut is locked away behind drywall. Municipal inspectors, often juggling 30 or more jobs a day, check that a header is present, not whether it matches the engineered requirement. The result is a structural weak point that remains invisible until years later, when the first signs of failure appear under the weight of a heavy roof or a winter storm. A single arc of electricity hidden in the walls or beneath a slab can ignite a fire that destroys a home before anyone smells smoke. The National Electrical Code, Article 210.12, requires arc fault circuit interrupter AFCI protection on all 120-volt, 15 amp and 20 amp branch circuits in bedrooms, living rooms and most finished spaces. Yet in many new homes, these breakers are missing. Electricians know the difference. A standard breaker costs $5 to $8, while an AFCI breaker runs $35 to $45. The savings add up for a builder wiring dozens of homes, but the risk falls on the buyer. NEC 300.4 also spells out a minimum burial depth for underground wiring, 12 inches unless protected by a GFCI or AFCI and encased in thick concrete. In practice, crews often run cable just below the surface, sometimes only 6 inches deep, to speed up trenching and backfill. Once the soil is replaced and the sod is down, no inspector can verify the depth without digging. Municipal inspectors typically check the panel label, not the function of each breaker. AFCI testing requires a device most inspection officers do not own. One veteran electrician puts it bluntly: the sticker on the panel means nothing if nobody presses the test button. The result is an invisible hazard, waiting for a chewed wire or a nail through drywall to trigger a fire. According to the US Fire Administration, electrical failures cause about 51,000 house fires and $1.4 billion in losses each year. The code is clear, but the inspection system rarely catches what matters most: the spark you cannot see. Water doesn't need a gaping hole to get inside a home. Sometimes all it takes is a thin strip of metal installed upside down. In North Carolina, a couple closed on a $650,000 house, confident that price alone would guarantee a solid build. Months later, they noticed musty odors and faint stains creeping along the baseboards. A contractor traced the problem to the windows. The flashing, a thin aluminum piece meant to direct water away, had been installed backwards. Instead of shedding rain, it channeled water behind the siding and into the walls. According to the International Residential Code R703, flashing must form a continuous, self-draining plane, but field crews often rush the job or rely on the cheapest material. Here, the builder used thin aluminum, bent on site, and skipped the manufacturer's sequence. No one caught the mistake at rough-in. By the time the homeowners discovered the damage, water had rotted framing, spawned mold, and compromised the air quality throughout the house. The repair bill landed between $25,000 and $30,000, nearly 5% of the home's value. The homeowner later said they never imagined something this basic could cause so much damage, or that it could be hidden so well. Flashing errors like this aren't limited to budget builds. Envelope failures cost United States homeowners over $1 billion a year, and the inspection system rarely demands a final envelope test before closing. With the damage sealed behind siding, the real risk is invisible until it's too late. Hidden behind drywall and attic insulation, the home's ductwork tells a costly story. Manual D, the industry standard for duct design, sets strict limits. Duct leakage must not exceed 6% of total system airflow. But Department of Energy field tests reveal a different reality. The average new home loses 30% of its conditioned air to leaks. That's 5 times the allowed maximum, with some homes losing even more. The ducts themselves are rarely tested. Most building inspectors check only that the HVAC unit is installed and powered, not whether the system actually holds pressure. According to ASHRAE 62.2, proper ventilation rates are essential for indoor air quality. Yet leaky ducts can send cooled air into crawl spaces or attics, leaving rooms stuffy and humid. One technician puts it plainly: if you don't run a pressure test, you're just guessing. The result is a perfect recipe for energy waste, high bills, uneven comfort, and hidden mold. These problems start small but grow expensive, all because the real defect is sealed out of sight. A cracked foundation slab rarely tells its full story on the surface. To uncover what is hidden, forensic engineers use a core drill to extract cylinders of concrete, revealing the truth about strengthened steel. The International Building Code, Section 2104, requires foundation concrete to reach at least 3,000 pounds per square inch. A CIA 615 sets the standard for reinforcing bar, typically number 4 rebar spaced every 12 inches. Yet core samples from homes in Texas and Arizona show rebar spaced at 18 inches or more, and cylinder tests often fall short of the minimum strength. These shortcuts are invisible once the slab is poured, but their impact is not. When settlement or cracking appears, repairs can run from $80,000 to $120,000. One engineer explains, you can't see the missing steel or the weak concrete, but they decide whether the house stands or sinks. Municipal inspections rarely require core testing or verify rebar placement beyond a quick glance before the pour. The most expensive and hardest to detect failures are locked in before a single wall goes up. Municipal inspection logs from Texas and Florida show a single inspector can be responsible for 250 to 300 homes a year. In practice, that means just 2 to 3 hours per house, barely enough time for a visual sweep, let alone detailed testing. The American Society of Home Inspectors' own survey confirms this workload, and most inspections stop at what can be easily seen: a quick look at the grading, a glance at the panel, a walk through the attic. There is no grade-level survey, no blower door test, no duct pressurization, and no requirement to check vapor barrier integrity or rebar placement after concrete is poured. One municipal permit auditor describes batch approvals as routine. We'd sign off on a stack of permits based on paperwork alone, sometimes without ever setting foot on site. ProPublica's investigation into South Florida exposed falsified foundation inspection reports, including missing cylinder tests. In that case, the inspector-to-inspection ratio reached 1 to 300, making on-site verification impossible. Across the country, as many as 14% of inspections are signed off with no site visit at all. The system is built to catch what is visible, but every shortcut in the 7-level ladder is designed to disappear before the inspector arrives. Without mandatory performance testing, the most expensive and dangerous failures remain locked away, invisible to buyers and unaccountable to the agencies meant to protect them. Today, homes in high-growth states face mounting risks, while inspection standards remain rooted in visual checklists and code minimums. A missed vapor barrier or miswired outlet can snowball into 5-figure repairs. The system rewards shortcuts, not safeguards. The real cost? Trust, safety, and the illusion that someone else is watching.